November 29th, 2011, we're doing lesson 6.5. So we are using all of the formulas and knowledge we have about quadratics to solve word problems. So the very first word problem we're going to do is example 2 in your book. And this is on page 307. It says a rectangular park measures 100 meters by 60 meters. So, rectangular park. It measures 100 meters by 60 meters. A path of constant width is to be paved around the perimeter. The mayor wants to be sure that the path does not reduce the area of the grass by more than 10%. What is the maximum allowable width of the path rounded to the nearest tenth of a centimeter? So, he wants some kind of path. Well, try to make sense of this. It will be a consistent path of the same width. Okay? And I should have. So essentially, they want some kind of path that is the same distance. We don't know how far this distance is. Okay, we're going to give it x. It's going to be the same distance all the way around. Okay, and they're going to pave it. So in other words, they're talking about this green part here. This is the path. Now they want the path to not reduce the size of this by more than 10%. So in other words, it still has to stay at 90% of the original area. Okay? So let's find out, first of all, the actual original area of this thing. The original area, so area of the original, is 60 by 100. Okay? Which is going to give us 6,000. 6,000 meters squared. So that's the original area. Okay. Now we know that we're going to have to create a new area, which will have this width and this length. Okay. We also know that the area of that object is going to have to be what percentage of the 6,000 meters squared? Got to be at least 90%. We can only lose 10%. So if we're going to lose 10% of this, that means we're talking about 90%. So we're going to call the area of the new object. We take the original 6,000, and we got to multiply it by 0.9. It's got to be 90% of that area still. So when we multiply this, we get 5,400. 5,400 meters squared. So the new area of our object and area of the new spot is going to be equal to the new length. So we'll say the length of the new and the length, not the length, the width of the new one. I'm putting these little subscripts so that you know which object we're dealing with. Okay. So the new area is 5,400. Now the new length. The new length, we know, the old length went from here to here. The new length goes from here to here. So essentially, it is the old length with what? Minus 2x. We're subtracting this part here, which we don't know the distance. We gave it x. And we're also subtracting this part here. The original length was 100. We have 2x. So our new length is 100. Subtract 2x. That's the length of this new area here. 100, subtract 2x. Our width, our original width, I guess I should keep it in blue. Original width is 60. What is our new width? Same idea. We know that this is x and this is x. So we have to subtract both those x's from 60. So the new area is 60 minus 2x. So we put it down here. We did the length, and we'll have to multiply by the width. So we have 60 minus 2x. So now we've set up our equation. And we're going to solve this. I need to put it in what form in order to use the factor or to use the quadratic formula? Standard. So in order to put this in standard form, I need a FOIL. I have 5,400 is equal to 6,000. That's 100 times 60. 100 times negative 2x is negative 200x. Negative 2x times 60 is negative 120x. And negative 2x times negative 2x is positive 4x squared. Okay. I'm going to collect like terms and put this in order of degree. So we have 5,400 is equal to 4x squared. I'm going to combine negative 200x minus 120x. What does that equal? Negative 320x plus 6,000. Now, in order to use our quadratic formula or to be in standard form, what does it have to be set equal to? 0. So I need to move 5,400 to the other side, which means our equation will now read 0 is equal to 4x squared minus 320x plus 6,000 minus 5,400, which in the end gives us 0 is equal to 4x squared minus 320x plus 600. Now, I could factor this. I'm going to tell you right now, it could be quite a bit of work. What can I put this into to make sure I know I'm going to get the right answer right off the bat? I can put this right into the quadratic formula. So I'm going to do that. We're going to take our quadratic formula. So, we're starting again. We take our quadratic formula. We're going to plug our values in. I'm going to start back in black again. So, negative b. b is negative 320 plus or minus square root of negative 320 squared minus 4 times 4, which is our a, times 600, which is our c. 2 times 4 divided by a. We're going to get positive 320 plus or minus the square root. Let's find negative 320 squared positive 102,400. And then we take negative 4 times 4 times 600 minus 9,600. 4 times 2? I knew that one. So, 320 plus or minus now we need to subtract 102,400, subtract it by 9,600. We get 92,800. Divided by 8. We get 320 plus or minus the root of that, 304.6. 0.63 divided by 8. We'll split our equation. X is equal to 320 plus 304.63. X is equal to 320 minus 304.63 divided by 8. All right, so let's equate these two numbers. We get 320 plus 304.63 divided by 8. 78. 0.1. Rounded after. And our other answer, 302, subtract 304.63 divided by 8, 1.92. All right. So our two x-intercepts, 78.1 and 0. And 1.92 and 0. So what they're saying is, do we get a negative or positive vote? There are two possibilities for widths of this path. Okay? So we're going to have to check them because we have two answers, which means we have two x-intercepts. So we're going to check it on the next page here. The two possibilities, we can reduce the path sizes by 1.92 meters, or we can reduce the area by 78.1 meters. Remember our original question? We had rectangular pathway built around a park. Oh, don't worry, it'll be fine. Okay. So we need to figure out if the reduction, if the path width should be 1.92 meters or 78.1 meters. So remember, our original paths were 100 meters and 60 meters. I just want to quickly, I want you guys to make sense of it. If we reduce the width by 78.1 meters on each x, are we going to have a positive number? We'll have a negative number. Is it possible to have a negative number in terms of the width of a part? No. So this is very illogical. Let's test our other answer as being the x values. Okay? Remember our length and our width for our new area. Our length was 100. Subtract 2x. This is our x value. And 60, subtract 2x for the width. Our area needed to be 5,400 roughly. Okay, remember we rounded this number, so it may be a few decimal places off. Let's find out. 100, subtract 2 times 1.92. And 60, subtract 2 times 1.92. We're going to work this out. We get 100, subtract 1.92 times 2, 3.84. And 60 subtract 3.84, which will give us 100 subtract 3.84, 96.16. So our new length is 96.16 meters, and our new width is 60 subtract 3.84, 56.16. Now we need to make sure it was roughly our new area, so we'll multiply those two numbers, 56.16 times 96.16, and we get 5,400.3. Okay? So it is roughly, it is approximately equal. 5,400 is equal to our 5,400.34. So we saved a little space. Remember, we couldn't go over our losing more than 10% space, so this worked out perfectly for us.